All right, so the first theory we're going to look at is valence bond theory. And so valence bond theory states that a covalent bond is the overlap of half-filled orbitals. Remember, orbitals can contain 2 electrons, so the idea here is when you have a bond, you have 2 half-filled ones, so they combine to completely fill it. And so if you look at hydrogen, it works pretty well for hydrogen. So you have a 1 electron in the 1s system, and so you have a hydrogen here in their 1s system, and then one has an electron, and the other one also has an electron, and then they're going to combine together to form a bond. And in this bond, each hydrogen donates 1 electrons in this overlap of their orbitals. And so we saw this similar picture earlier. It's essentially the same picture here, right? 2 hydrogens move close together until the overlap is optimal. So let's take a look at H2S and see the Lewis-Vesper idea and the valence bond theory. So if you think about H2S in your Lewis structure, you would draw something like this. And then if you think about the shape, the electron geometry is going to be tetrahedral, and so this shape is going to be end up being bent, and so then this will be less than 109.5 degrees. If we take a look at the valence bond theory side of things, we have an H in its 1s orbital with 1 electron, and then over here we have sulfur. Sulfur has 6 valence electrons, so let's go ahead and draw that. 2 in the 2s, and then 4 in the 2p. So 1, 2, 3, 4, oh, oops, 3s and 3p. And so you can see there's going to be 1 bond forming here between this half-filled orbital and this half-filled orbital. And then another one to bond with this half-filled orbital. And so you can see both of them predict H2S, which is looking good. And then if we were trying to kind of draw the structure of what this would look like, we would think our sulfur with our s electrons in there, right? They're not going to be bonding. Then you have a filled p orbital. Let's make this one kind of blue. And then you have 2 half-filled orbitals. So you kind of have one coming out of the board, half of one orbital, and then the other half of the orbital is going into the board, an electron there. And then you've got this p orbital going into the board, and then on the other side, this coming out of the board. And then there'll be 2 hydrogens on either side. And so if you think about the bond angle predicted here, it's going to be 90 degrees, right? So one predicts 109.5, the other predicts 90 degrees. So which is correct? So to take a look at that, we'd have to take a look at the actual molecule, and the actual bond angle is equal to 92 degrees. So in this case, valence bond theory is more correct than the Lewis structure. And so although valence bond theory is more correct than Lewis and Vesper in this case, more oftentimes Lewis is better. And we'll see an example of that coming up.